Alright, today we're going to start our Chapter 6, Trigonometry, which is on trigonometry identities. So we're going to figure out what an identity is, and we're going to look at the basic ones today. A little bit different in this unit, because a lot of times with identities we're not really solving anything or doing anything different, we're just sort of proving that something can be rearranged in a different form. If you think back to our last couple chapters, we know that trig equations can be written in many different ways. And when we looked at graphs, we could translate them left or right for a sine, or somewhere over to get a cosine. So there's lots of different equations to give you the same thing. And that's sort of what a trig identity is based off of, is there's more than one way of writing a trig equation or a trig function, and we still get the exact same thing. So for it to be an identity, what that means is it's got to be true for all possible values on both sides of the equation. And the key thing is it has to work for every possible value. So every x value for up to infinity and negative infinity in the other direction. So the first identities that we're going to look at are three that we've already seen before. So when we deal with cosecant, secants, and cotangents, we remember that they're just the exact same thing as 1 over sine, 1 over cos, or 1 over tan, respectively. The new ones we're going to look at are also ones we've sort of done before. So remember, if we do a unit circle thing and we look at something like 30 degrees, we know the sine of 30 was a half, the cosine was root 3 over 2. So therefore the tangent, if you remember the tangent, we could write that as 1/2 over root 3 over 2, which then simplified to 1 over root 3. So when we did tangents, we actually were basically doing sine divided by cosine. And then because we know cotan is 1 over tan, we could also then write it as cos over sine. So typically what we do with our main identities is we use our cosecant and secant, we write them as cos x. And then if we had a tan, we usually write it as sine over cos. And if we have a cotan, we write it as cos over sine. So those two identities, so we often mix those two together. So we basically use sine and cosine as our regular ones, then cosecant and secant, we do 1 over sine, 1 over cos, and then tan and cos, we do sine over cos or cos over sine. The other ones that we're going to use quite often are Pythagorean. So based on, if we go back to our unit circle again, and if we look at 1/2 and root 3 over 2, we know that for it to be on the unit circle, using a squared plus b squared equals c squared. So we know that our sine was 1/2, and we know that our cosine was root 3 over 2. So that is indeed true, but we don't actually have to do this for just a 30-degree triangle. We can do it for any angle. So we know that based on Pythagorean theorem that our sine squared plus cos squared will equal 1. So it's just a simple Pythagorean theorem identity. The other two are just basically modifications. So if we start with our original, and let's suppose we take our original and we divide it by cosine squared. So if we divide everything by cosine squared, we have sine over cos, which is tan, cos divided by cos, which is 1, and then 1 divided by cos, which is secant. So really, the regular equation divided by cosine squared equals the bottom one. And we could basically do the exact same thing again, where we go take the original and divide by sine squared. So if we divide by sine squared this time, sine divided by sine is 1, cos divided by sine is cotan, and 1 divided by sine squared is cosecant. So all three of these identities are really the same thing, just different ways of writing them. So couple of things to remember is when you see something like sine squared or cos squared or anything like that, what you want to do is automatically think of one of these identities. But it's also important to remember that that means sine x squared, which would mean sine x times sine x. When we get into further identities, quite often we're going to want it written like that. So sine squared in the middle means same thing as one of them squared, which means we basically are multiplying two different things. So we're going to look at a couple different methods of what we do with these identities. So the first one is substituting. So to verify an identity, we can substitute a given value in and see if it actually works or not. So we want to check to see if cosecant x equals cotan over cos. So if we take the original and we put in cosecant of 45, and we want to see if that's going to be the same thing as cotan 45 over cos 45. So just plug it in on your calculator. You can't type in cosecant, but we can write in 1 over sine. And for cotan, we can write it as 1 over tan. So on your calculator, just type in both of those. And if you do exact values, you actually get root 2 for both sides. So 1.4, whatever root 2 is, so we indeed see that it's true. So just by plugging in a number, we see that it's true. But the key is that that's true for 45 degrees. And remember, we want to prove that this has to work for all values. So we need to get every possible value of x working. So it doesn't make sense to try in every value of x because it's impossible. We can't do an infinite number of solutions. So it works good to verify that an angle is correct, but it doesn't work as a proof. So another way to do this is to actually graph these things. So if we, on your calculator, if you graph cosecant x, you'd end up getting sort of a weird looking graph that looks kind of like that. And then all we have to do is graph our second side, graph in cotan over cos, and we just see if our graph looks the same. So when we graph the second one, we're going to get the exact same graphs overlapping. So it's a little bit better and quicker way to prove to see if something's the same or not. But once again, remember this must work for all values of x. So when we look at the graph, I just did like maybe from negative 360 up to 360. That works for those ranges, but it doesn't necessarily mean it works for all possible. So graphing is kind of like plugging in a number. It works for certain values, but not for everything. So what we want to do is prove this for any possible case. And to prove this, we want to use identities. If we rearrange to identities, then we know for sure it works. So to be an identity, that means it already has to be proven to be every possible value. So to do an identity, what we want to do is usually change things to sines and cosines and then rearrange and simplify from there. So with cosecant, we know that's the same thing as 1 over sine. Cotan we know is cos over sine. And we're dividing that by cos. So because we got a fraction here, let's simplify that a little bit. So that would be cos over sine for our top. We're going to multiply that by the reciprocal. So we have like cos over 1, so when we do the reciprocal, that would be 1 over cos. And that's it. Once we do that, we can see that we get the coses canceling. So we have 1 over sine on the one side and 1 over sine on the other side. So by proving that both sides are the same, we indeed prove that this is true. So let's try another one. Here we got tan cos. So once again, let's change everything to sines and cosines. So tan would be sine over cos, and we're timesing it by cos, so let's put it as cos over 1. Then on the bottom we got secant, so that's 1 over cos, and cotan would be cos over sine. And let's just leave the other side the same for now, sine squared. So now we can see on the top we get the cosines canceling, and on the bottom we get the cosines canceling. So this simplifies to sine x over 1 divided by 1 over sine x. So let's multiply those out. So sine x over 1 times the reciprocal, sine x over 1, and sine x times sine x is sine x squared. We got 2 of them, so we've gone far enough. We've proved this to be true. So let's try one more. We got cotan squared minus cosecant equals negative 1. Quite often, anytime you see squareds and equal to 1, things like that, that's likely going to be one of the Pythagorean identities. So we want cotan, cosecant. So let's go back to our list to see which one was which. And all of these are on your formula sheet. Let's go back to the list to see which one. So we got cotan plus 1 equals cosecant squared. So that's likely going to be the one we want. So let's go back to our question. So it was cotan squared plus 1 equals cosecant squared. So you can see this is indeed the right formula, it's just it's been rearranged. So we know that if we bring cosecant over, so we can just basically simplify by moving the cosecant over. So we'd have cotan squared minus cosecant squared plus 1 equal to 0, and then let's bring the 1 to the other side. So we have cotan minus cosecant. Oops, that's all messy. And bring the 1 to the other side, that gives us minus 1. And that's it. We've actually already proved it because all we had to do was rearrange the main equation that was given to us. So that's the simplest way to do that one. There's other options. You could try switching things to tans and so on. There's lots of different choices for this one. So I would say that's the easiest way. Just rearrange that simple equation and you're done.